Hello everyone, myself J. Vinay Kumar, and the subject which we are going to deal is DC machines and batteries. In the previous presentation, we have learned about the back EMF, significance of back EMF, and the equations of back EMF, and also we have solved some problems on back EMF of a DC motor. And the main objective of this presentation is to know about the torque equation of a DC motor, and also we will be developing the formulas for armature torque, which is represented by TA, and shaft torque represented by TSH, and we also going to learn about the loss torque. After that, we will be solving some problems on torque equation and also on speed. Now let us know what is a what is torque. In this diagram, it is clear that there is a pulley whose radius is smaller and it is rotating at a speed of n rotations per second, and the force acting on the pulley is capital F. Actually, what is torque? The torque is nothing but it's a turning or twisting movement of a force about an axis. And torque is nothing but it is the product of force and radius at which the force acts. Now, if we write the equation for this pulley whose radius is r and the circumferential force is F newtons and it is rotating at capital N rotations per second. Then the equation will be torque is equal to force into radius, that is F into R Newton meters. And if we write the work done by this force in one revolution, we get F into 2 pi R joules. Nothing but force into distance. And the same work, if we write in seconds, that is if work done per second, then it is written as F into 2 pi R into N joules per second. And the mechanical power developed is given as F into R into 2 pi N by 60 watts, where 2 pi N by 60 is nothing but it is the angular velocity in radians per second. And we also know that force into radius is nothing but torque represented by T. So from this the power developed P is equal to T into omega. You can write it as 2 pi N T by 60 watts. This power is developed in the armature. Now let us see the armature torque equation of a DC motor. Armature torque is nothing but it is the torque which is developed in the armature. Let TA be the torque developed by armature of a DC motor running at capital N rotations per second. Then TA can be written as the mechanical power developed is equal to TA into 2 pi n by 60 watts. And the electrical equivalent of mechanical power developed by the armature is equal to EB into IA, where EB is the back EMF and IA is the armature current. If we equate the above two equations, can write as TA into 2 pi n by 60 is equal to EB into IA. And we also know that the back EMF, which we have already seen in the previous presentations, EB is equal to phi Z N into P by A by 60. Here phi is nothing but it is the flux in Webers, and Z is the total number of conductors, and capital N is the speed with which the armature rotates, and P is the number of poles, A being the number of parallel paths. If we substitute this EB equation in the above we get TA into 2 pi n by 60 is equal to 5Zn into P by A by 60 into IA. Here we cancel the terms common on both sides, that is n by 60 and n by 60. Then we get the equation for torque developed in the armature, TA, which is equal to 1 by 2 pi into 5 ZIA into P by A, Newton meter. If we solve this, 1 by 2 pi, we get the torque equation, which is developed in the armature as TA is equal to 0.159 5ZIA into T by A. Now let us see how much torque will be there at the shaft. Previous equation TA is nothing but it is the torque developed in the armature, and TSH is nothing but it is the torque available at the shaft. Now let us see that the torque which is available at the motor shaft for doing useful work is known as shaft torque, represented by TSH. The mechanical power developed at the shaft will be given as TSH into 2 pi n by 60 watts. whereas the motor output can be written as bhp into 735.5, equating the above two equations. We get bhp into 735.5 is equal to 2 pi n into tsh by 60. Here our aim is to find out the torque available at the shaft. So tsh is equal to bhp into 735.5 into 60 by 2 pi n. Now let us see the other torque, that is loss torque. The previous torques is nothing but one is TA, it is the torque developed in the armature, and TSH is nothing but it is the torque available at the shaft. Loss torque is nothing but it is the loss between the gross torque, that is armature torque, and net torque, that is the shaft torque. So this torque can be written as TA minus TSH. Let us see the gross torque or armature torque developed by the armature will not be available for doing useful work, because certain percentage of armature torque is required for supplying iron and friction losses in the motor. The difference of armature torque and shaft torque is known as loss torque or lost torque. and this lost torque is mainly due to iron and friction losses of the motor. We lose this torque mainly because of this iron and friction losses. And the lost torque is given as Ta minus TSH. Now let us see the next topic, that is the speed equation of DC motor. We know that the back EMF of a DC motor is equal to EB minus EB is equal to V minus IA RA, where V is the applied voltage, IA is the armature current, and RA is the armature resistance. And we also know that the back EMF equation is equal to phi Zn into P by 60A. On equating the above two, we get phi Zn into P by 60A is equal to V minus IA RA. From this, the equation for speed of a DC motor can be written as N is equal to V minus IARA by phi into 60A by ZP. And we know that EB is equal to V minus IARA. So we substitute that in this equation, then we get N is equal to EB by phi into 60A by Z into T. From this, N is directly proportional to EB by phi, or N is equal to K into EB by phi, where K is equal to constant, that is 60A by Z into P. From this equation, it is clear that the speed of the motor N is directly proportional to back EMF EB, and the speed of a DC motor is inversely proportional to magnetic flux per pole. Now let the initial values of speed, back EMF, flux, and armature current be N1, IA1, EB1, and phi1 respectively, and the corresponding values of the same speed, armature current, and back EMF and flux per pole of a DC motor are N2, IA2, EB2, and phi2 respectively. Then from the previous slide, we know that speed is proportional to EB by phi. From that, N1 is proportional to EB1 by phi1, and we know the value of EB, which is equal to V minus IARA. So the initial value of EB1 can be written as V minus IA1 or A, and the corresponding values for the same motor is N2 is directly proportional to EB2 by phi 2, where EB2 is equal to V minus IA2 RA. From that, if the motor is a series one, that is DC series motor, then the flux will be proportional to armature current. In a series motor, all the currents will be same. That is IA is equal to ISC is equal to IL. From that, we can write as N2 by N1 is equal to EB2 by EB1 into IA1 by IA2. This is the equation from the previous formula. That is N is directly proportional to, sorry, N is proportional to EB by phi, and EB is equal to V minus IA RA. And if it is a DC shunt motor, then the flux remains practically constant. So phi 1 is equal to phi 2. So from that, we can write as N2 by N1 is equal to EB2 by EB1. Now let us solve some problems on torque equations which we have learned in the previous slides. Now let us see the first question, that is a DC motor takes an armature current of 110 amps at 480 volt. The armature circuit resistance is 0.2 ohms and the machine has 6 poles and the armature is lap connected with 864 conductors. The flux per pole is 0.05 Webers. Calculate A. The speed. B. The gross torque developed by the armature. First of all, we have to study the problem thoroughly, and we have to know what is the given data and what we have to find. Here the given data is armature current is 110 amps and the number of poles is 6 poles, and since this is a lap wound DC motor, the number of parallel paths will be equal to number of poles. So P is equal to A is equal to 6 and the voltage V is equal to 480 volts, and Z, that is nothing but the conductors, is equal to 864, and the armature resistance RA is equal to zero point 0.2 ohms, and flux per pole is equal to 0.05 Webers. From this, the back EMF equation EB can be found by the formula EB is equal to V minus IA RA, which is equal to 480 minus 110 into 0.2. On solving that, we get 458 volts, and we know that EB is equal to 5Z by 60A. From this we can find the value of N on substituting all the other known values, that is 0.05 into 864 into N into 6 by 60 into 6. Then we know the value for EB also. Then we get the speed as N is equal to 636 RPM. RPM is nothing but it is rotations per minute. Here we have substituted A is equal to 6 because it is a lap wound DC motor. Okay. And to find the armature torque, it is also called as gross torque. TA is equal to, we know the formula, 0.159 into 5 into Z into IA into P by A Newton meter. If we substitute all the values, we get 0.159 into 0.05 into 864 into 110 into 6 by 6. We get the answer 756.3 Newton meter. Okay, in the next presentation, we will be solving some more problems. From this, we will be closing this presentation. Thank you very much for listening with.